The equation that we saw for mirrors is in fact the same equation we can use for lenses. F refers to the focal length of the lens, DO refers to the distance of the object from the lens, and DI refers to the distance of the image to the lens. Here you can see an example of how you can figure out those values. Now we also need to keep intact our sign conventions that we saw for mirrors. So, for F, a positive focal length will correspond to a converging lens. A negative focal length will be used when you have a diverging lens. For DO, a real object will be considered positive and a virtual object will be considered negative. Now what's the difference between a real and virtual object? Well, if the light actually comes from an object, it's considered a real object and we'd use a positive value. However, we may have a virtual object where the light appears to come from. So if there's no actual light converging where the object is supposed to be, which is the case when you have multiple lenses in some scenarios, then you may actually have a virtual object. But if you only have one optical element, one mirror or lens, this is probably going to be what you're going to use. Now for the image, if we create a real image where light rays actually converge, we get a positive value. If we create a virtual image where we have to trace back our rays, we get a negative value. Now we also have magnification for our lens system, and the formula is exactly the same. If you get a positive value, your object is oriented in the same direction as your image. If you get a negative value, your image is therefore inverted from your object.